Okay, we'll get started. Want to welcome everyone and thank you for taking time to join us for this webinar. Today we'll be talking about navigating manufacturing architectures on premises, cloud, or hybrid. Brought to you by OLSOM here. For an agenda, we'll introduce our speakers. We'll go over some of the architecture types and patterns, and go over some light definitions just to give context to the rest of the discussion. And then we'll have Radovan speak to the pros and cons of some of those different architectures. And then we'll close out with Yuri talking about the transformation from a legacy environment to a hybrid architecture environment. And we'll leave a few minutes at the end for Q&A. And as far as the Q&A, the meeting is being recorded and the attendees are muted, but you'll be able to type in questions. If you look at the bottom of the screen, you'll see the icon for the Q&A, and you'll be able to type screens in there, type questions in there, and we'll be able to kind of address those questions at the end. And if we don't have enough time to get to the answer, we'll reach out to you offline and exchange emails. So with that, we'll introduce our speakers. Myself, I'm Enrique Herrera. I'm working as an Industry 4.0 independent consultant with 20 plus years in digitizing manufacturing operations and working at a few technology and software companies as well. Joining me will be Radovan Vlach. And Radovan brings over 10 years of practical experience developing some of these mission critical manufacturing applications. And he's currently a full stack developer at CAE and an MES team leader. So we're very fortunate to have Radovan. And then also joining us will be Yuri Pilipenko, who is the founder and CEO of OLSOM as a well-recognized manufacturing solution with over 20 plus years also developing and launching some of these mission critical manufacturing solutions with experiences from a variety of esteemed companies. We'll hopefully have a fruitful discussion for you today. So we'll start talking about architecture and what it is and why it's important, and what are the impact of some of those decisions that are made early on in projects for architecture considerations. So we'll start. A lot of manufacturing enterprises start by looking at their overall enterprise architecture, which encompasses the entire business, including the multiple functional areas. And then from there, the individual solutions that support each of those functions. And with each of those solutions comes a technology or a technical architecture as well. And sometimes this solution and technology architecture are referred to as the IT architecture. As far as diving into the technology architecture specifics, we start with the components of the infrastructure, the physical infrastructure, the computing infrastructure, which can be made of edge computing, cloud computing type of computing platforms. And then we also refer to some of the data architecture considerations, whether that's the real-time operational data or the metadata and contextualization data. Also, there's considerations around integrating the different platforms, the physical and the software layer, and the various physical layers as well, and some of the software components to the solution. And today we'll be focusing on the manufacturing execution systems environment. So as far as some of the impacts of some of those architecture decisions that are made fairly early on in a project in terms of the time considerations, the cost considerations, and the implementation. Sometimes you need rather quick implementations because you're on tight timing, or sometimes you have times to plan out an overall architecture that will help with scalability and efficiencies and leveraging good practices. Obviously, doing it quickly can bring about some risks if you don't have a good design. So therefore, you need to take considerations of the future risks that you may be bringing. along with the ability to respond to future technologies and future-proofing some of these architecture decisions. Scalability becomes very important as you roll out to more and more sites, and making sure that you're repeating good practices, especially when it comes to integration, as some of the environments at the individual plants may not be the same. So in terms of some of the definitions that you'll hear, especially if you're talking to within the IT organization and along with the hyperscaler communities, they'll talk about a private cloud, which is mainly controlled by a manufacturing enterprise's IT organization, or a public cloud that can be brought to bear by a partner or company, a hyperscaler that enables the different cloud architectures. And we kind of itemize the three here in terms of infrastructure as a service, platform as a service, or software as a service type of architecture patterns. Now, when we take a look at some of those cloud configurations, and I know this is a pretty busy chart, but we'll look at on-premise, as I mentioned, controlled entirely by the manufacturing enterprise's IT organization, to the one all the way on the right, which is software as a service, where the third party controls all the components of the individual of the stack. And then a couple of other intermediate patterns, all dividing kind of the responsibility, where the light blue is kind of the responsibility of the enterprise customer, and the dark blue will be the responsibility of the third party providing that service. And Radovan will talk in more specifics as to some of these architecture kind of divisions of responsibility. One of the other considerations besides cloud, we also recognize we start talking about edge when this particular diagram, the field level infrastructure, which is the hardware and the sensors close to the initiation of the data source. So if we look at the cloud being kind of the final destination and the larger computing environment, and the field level being the edge with kind of more near real time, low latency, kind of fast computing environment, there's also a part of the solution architecture that's hybrid, where some of the solution components may exist on premises closer to those field level devices, but some of it may exist in the cloud to take advantage of some of the cloud services and scalability. So that is deemed as kind of the hybrid part of the architecture. And both Radovan and Yuri will talk about that a bit more. So with that, Radovan, I'll hand it over to you.
Thank you, Enrique. So let's start with the first architecture type, the one that probably most of us already knows and uses, and that's on-premises. So this is the type where, as the diagram on the left indicates, we take the full responsibility of all the components that make the solution. That means we have to handle networking elements, storage, servers, operating system, and MES application itself. This gives us some key benefits. And the one that is most often used is that there is no internet connectivity required, and that also allows us to operate in cases when the internet connectivity is unstable. Also, we have total control over the data, and it allows us to operate in highly controlled environments, for example, in defense sector. The on-premise architecture has advantages in the location. It means it's located in a close proximity to manufacturing location, and this brings low latencies, low communication latencies, and also it makes integration with legacy hardware easier, because these legacy components, they often cannot communicate with cloud services. Of course, there are some downsides to this architecture. The first one would be that typically there is a large upfront investment required because we need to purchase all the hardware and software licenses, and we need to plan for the requirements, not just current requirements, but also the requirements that we will have in 2-3 years. So, and this maybe these requirements will come, maybe they will not. So this might be a waste of resources if in certain cases. And the on-premise architecture is also difficult to scale, as procuring servers or software licenses is often expensive and time-consuming. So now let's take a look if there is other architecture that can help us to address some of these shortcomings. So we can host our MES in the cloud, and cloud offers us three basic type of options. The first one on the other slide would be infrastructure as a service. That is a case when the hardware itself is managed by cloud vendor, and the rest of the solution is managed by us. It's useful in cases when we need to migrate on-premise servers to cloud to address some problems with stability, or maybe our servers are getting to their end of life, but we still need to maintain them. More effective use of cloud resources would be platform as a service, where we don't have to manage operating system and the runtime itself. We just migrate the MES itself and the connected database, for example, Microsoft SQL Server. That's more effective. And the last option that is easier to begin with, that's a software as a service, where the cloud vendor handles all the technical aspects of the solution, and we just get the benefits and pay the monthly bill for it. So let's take a look at some of the cons and some of the pros that are common to all these cloud offerings. So the first pro that I see as the very beneficial, it's consumption-based pricing. So it's very easy to start working with cloud services, and we can, for example, introduce a system for OE monitoring on our legacy devices or machines, and started with a limited set. And once it's proven that it brings us some benefits, we can scale it to a larger set of machines. And by using cloud resource monitoring tools, we can scale up the cloud resources only when it's necessary. So we don't have to procure the resources from the beginning, but only when needed. That is something that it's possible only in cloud, and it's important to do. Otherwise, we would have to pay for the resources we don't use. So please keep in mind that all the cloud resources can be easily scaled, and usually it's just a click of button away. So another benefit is that the cloud resources are very easy to set up in a geographically distributed environment. So if we have multiple plants spread across the world, again, by a click of a button, we can set up a new MES servers that are located closer to plants in Asia, in the US, or Europe. And the last aspect I often use is that the high availability is built into the cloud, and we don't have to worry about the reliability because it works by default. Then there are, of course, some downsides related to cloud solutions. One of them is that in cloud solutions, there is a little bit higher risk of getting into vendor lock-in because a lot of cloud platforms, they offer unique type of solutions, and these solutions cannot be transferred to any other providers. So it's better if we use open standards and protocol as much as possible. And usually these open standards are supported by these cloud platforms. And another con that I could mention is the latency. So in certain cases, we have a problem with data center location, and the data center location can be further away from our plants, and that can introduce 100 millisecond, 200 millisecond latency into the communication, and that can cause issues with real-time applications. But there are ways how to overcome this problem, and that's hybrid version of the architecture, and where we run the payloads in cloud on edge. So in this case, we run the bits and pieces that are necessary for the MES to function and respond very quickly. We run them on site, and we use cloud services to store, for example, historical data and run analysis on them, or we can connect the cloud data to artificial intelligence. And with that, I would like to invite Yuri to continue with sharing more details about the hybrid solution.
Okay, thank you, Radovan. So what is the hybrid architecture for manufacturing execution system? So when we are talking about the hybrid architecture, obviously there's cloud computing and edge computing, and the our customers often ask the question, what functions should be, how the function should be distributed? What is supposed to be located in the cloud, and what is supposed to be located in the edge to provide the highest benefits of both and get the maximum from the from your hybrid. So I typically distribute all the functions in 3 groups. That is operations, analytics, and insights. Actually, analytics and insights are related because we are using the analytics to generate insights. And then insights trigger the actions to the operations. And obviously, the easiest way is to get, for example, if you have today on-prem, the easiest way to get to the cloud is what we call the thin, to have the thin edge, where you put all of the business logic in the cloud, leaving some basic, like data transformation or aggregation in the edge. But this thin edge architecture would typically work if you don't have any requirements or any limitations to your operability of your system or latency. However, we know that manufacturing execution system is typically a mission-critical application, meaning that it's highly demanding to its availability and latency times. Or by latency, we are talking about the real time. So it has to be like really real time. And we know that some of our customers demanding to have their system be capable to run 48 hours without internet. Therefore, we are leaning more towards another solution where we relocate the operation, the shop floor operations management in the edge and run it on-prem. That approach would require the separation of your data model in two. So the one that would be keep the ongoing real-time data, maybe, like 1 month or a couple months worth. And then the in-cloud database that would keep a historical big data, and that would be used for running the analytics and generating insights. So this approach is more practical if we want to secure the high operability level of the manufacturing execution system. And that's the approach that we typically go with when deploying the hybrid solutions to our customers. So then the next question would be, okay, we got the how these functions, how the MES functions would be distributed between the edge and the cloud. And going, like more in detail, we typically take the ISA 95 level 3 for production operations management. Well, as an example, we've got here on the slide only the production operations management, but pretty much it will be the similar picture for quality operations and for maintenance operations. So we've got 7 major activities defined by ISA 95 for MES. And this slide shows how we distribute this activity, the functions of these activities between the edge and the cloud. So as mentioned earlier, the edge in our case is responsible for real-time operations, while the cloud is focused on the centralized big data processing. So first three activities of the ISA 95 are related to definitions, product and resource management, and production schedule. And those functions are managed on the edge side in our case. However, the cloud is used as a centralized data repository that can be shared between the multiple sites or within the organization or multiple applications. Then the next 2 items are 2 activities like production, dispatch, and execution management. They're related to the operations execution, and those 2 are completely performed on the edge side. During the execution, we are collecting the data, and that's going to be like big amount of data. But we would not keep all of that on the edge. We would only keep those information that is important for real-time visibility and alarming. All the historical data will be transferred to the cloud for further organization, contextualization, and eventually used for reporting, historical reporting, analytics, and generating the insights. All right, so getting, like clear on this, like function distribution. Now the question is, okay, I've got, like a brownfield, and I have some legacy MES system. Can I transform my on-prem legacy system to hybrid? And here we don't have the direct answer, yes or no, because there are like multiple constraints that have to be considered to give the answer yes. And we can group these we can group these constraints in three groups. The first one is related generally to the enterprise policies. So does the enterprise policy allow the data in the cloud? That's the first potential roadblock from moving to the hybrid. Another constraint is the architecture of your existing MES. So the question is, does the existing architecture allow to separate the data model, to split the data model, and move the analytics piece to the cloud? And here we have to consider that the MES have to be the modern, have to have the modern web-based architecture based on APIs, etc. And also it has to be quite modular because you would need to separate the operations from the analytical piece. And the last but not least is the availability of the competences. It's quite important to have the right people in the team. First of all, database competences is important because you would need to separate the data models in two and run the synchronization between them. And the last but not least is security competence. We are talking about this information security or cyber security, because once you move the analytical piece to the cloud, it is important that you have, like your communication, your synchronization of data, and your application is protected from the security threats. All right. So once you say, okay, I am good and all of that is met and I can move forward, what would be my roadmap transformation of transformation? And the first step we would typically start is the separation of the database bases in analytical and operations. Showflow would run on the real-time operational database, while the office would use the analytics for and generate the trigger the actions for the continuous improvement of your operations. And once this is done, and during the split, it is highly important to consider the link between these two databases, how the data synchronization would be organized. It has to be effective, and it has to be, like secured. So you can use like HTTPS. I'll think about some VPN or other form of connectivity, but you need to think during the database separation phase. And once it's done, you are good to move the analytical piece to the cloud and use the power of the cloud to big with the historical big data and generating the insights that would be used to trigger the actions for your operations improvement. So that's basically it from the first glance. Sounds easy. In reality, it's a little bit more difficult, but yeah, that's probably the way to go.
All right, thank you, Radovan and Yuri. Let's take a look here. Let's see, we got some questions. First question here for both of you is, are manufacturers leaning towards a particular cloud architecture? Radovan, what are your thoughts?
I would say that most of the manufacturers are leaning towards on-premise because that's what they have, and it takes time to move or change the architecture. It's difficult to change, but I would say that for greenfield deployments and for modernization projects, they're definitely going into more hybrid approach, because that gives them the best benefits from both worlds.
All right, and let me add here that in the hybrid approach, that there was one of the major cons of the on-prem, that you're that it's difficult from the very beginning. If you're planning the greenfield, it's difficult to assess your resources like memory, like of your computing resources. And in case of the cloud, since we are pushing, like the historical data outside to the cloud, in case of hybrid, and we keep only a small database that keeps, like the real-time data or very close to real-time data. So it's much easier to assess the resource, the capacity that is needed.
No, that makes sense. I agree with taking advantage of the elasticity of the cloud computing so that you can start with a fixed kind of set of resources locally on-prem and then allow the elasticity of the cloud. So if you wind up being slower or faster, then you're not underutilizing those resources. I would agree with that. Let's take a look at another question. There's a question here that says, are there any tools available to help keep the data synchronized in a hybrid architecture? Yuri?
We are working mostly with, the tools would be limited by the databases that you are using. We are utilizing in our solution, we are utilizing mainly Microsoft SQL, and therefore we are leaning towards replication, EDL and replication. However, I know that Radovan has experience working with different databases, so maybe you can extend the answer.
Yeah, so another option would be to use event-driven databases, where we replicate just the events as they happen. The problem here is that the software architecture needs to support this type of databases, and as this is something pretty new to this world, only a limited set of software designs and tools exist that would allow us to deploy this to the shop floor environment. So it's mostly I see it as a future, but there are still some questions that needs to be answered.
All right, I think we have time for one more question here. We have here, is it preferable to start in a multi-factory environment with a greenfield or a brownfield site? Radovan, what do you think?
Well, I would say I like starting on the brownfield because that can demonstrate the elasticity of the cloud. So you can start adding small bits of cloud functionalities to the existing solution, and you can see immediately the benefits it can provide to you. So that's what I prefer. And it's also easier to get buy-in from management if we go this way, because, as I said, they immediately see all the benefits.
Yeah, very good. Yuri, do you have some thoughts?
Yeah, I agree with Radek. However, going with greenfield is always easier in terms that you're not impacting any current operability, and it's like a greenfield. Why wouldn't you lay the right architecture in the very beginning, right?
Yeah.
It's
definitely a question of risk, right? And how aggressive somebody wants to be fully cloud or hybrid. So with that, I'll invite you to kind of book a demonstration of OLSOM's AGW solution. You can scan the QR code here, or you can kind of follow us on LinkedIn or YouTube. And then our contact information there, if anybody would like to follow up with any one of us on this topic or maybe future topics for webinars. So with that, I'll close this out. And thank you very much, Yuri and Radovan, for your participation. And thank you very much to you all for joining us for this session. Thank you.
Thank you, Enrique. Thank you, Radovan.
Thank you.
everybody.
Cheers, guys.